Welcome to The Sleepy Physicist. I'm glad you're here. Whether you're in bed wrapped in a blanket or just finding a quiet moment, I've created this space for you. It's a peaceful corner where we can contemplate the universe. Tonight, we'll gently explore one of the cosmos's most profound mysteries, black holes. We won't approach this like a strict lesson but more like a relaxed conversation between two people marveling at the stars. I've tried to make this as calming as possible, but black holes are so fascinating that your mind might get excited. If it does, don't worry. Your curiosity will eventually lead you back to sleep, a bit smarter and more amazed. If you're enjoying this, feel free to like or subscribe for more relaxing science stories. I also love to see where everyone is listening from, so let me know in the comments. Just a reminder, this video is for educational and relaxation purposes only and should not be a substitute for medical advice. Now let's begin. The cosmos and stars lie back, take a deep breath, and gaze up at the vast, ancient night sky. Although you can't hear it, the stars hum, and though you can't see it, space isn't empty. It's full of gravity, motion, and memory. The stars you see are like historical messages. Their light has journeyed for years, decades, or even centuries just to reach your eyes. A star you see tonight might have died long ago, yet its light, like a late-arriving letter, continues to hold meaning. In the dark voids between those stars, something else exists: black holes. They are invisible because they don't emit light and move silently, like hidden punctuation marks in the universe's grand narrative. What a black hole is: a black hole isn't a physical object, but a region of space where gravity is so overwhelmingly strong that nothing, not even light, the fastest thing in existence, can escape. It's not a void like a hole in the ground, but a powerful gravitational field where time, light, and matter are pulled inward, with no possibility of return. Black holes form when massive stars meet their end. The largest stars burn through their fuel quickly and die in a spectacular collapse. While most stars become a gentler white dwarf or a neutron star, a sufficiently massive star will collapse past all resistance, beyond atoms and even time, leaving behind an absence, a profound silence contained by gravity. The dance of black holes, our galaxy, is likely home to dozens, if not hundreds, of black holes, silently drifting and influencing distant star systems. But what happens when they encounter each other? In the immense stillness of space, black holes move, drift, and orbit. When two of them get close enough over millions or even billions of years, they begin a cosmic dance. Their powerful gravity locks them into a slow orbit, like two ghostly partners spiraling closer. As they do, they send out invisible ripples called gravitational waves through the very fabric of space. You can visualize this like a soft, stretched sheet. The black hole's motion tugs and trembles the fabric, sending out gentle pulses that carry the history of their movement across the universe. These waves, though too faint to be felt, are real and may be passing through you even now, like a subtle heartbeat beneath all matter. The final merger, eventually their orbit tightens, and the black holes fall inward faster and faster, until they merge into a single, larger black hole. This fusion releases an immense burst of energy that can't be seen or heard, only felt as a silent stretching of spacetime. However, the most beautiful part of this process is its incredible slowness. Black holes operate on deep time, where 1,000 years is just the beginning of their patient journey. The universe is not in a hurry, and tonight, neither are you. As you drift off, know that far away, two unseen giants might be slowly circling each other, pulled together by an ancient, inescapable force. You don't need to grasp every detail to appreciate the poetry in it. Just breathe and let your mind float freely, like starlight, slow and weightless. A closer look at gravity as you rest. Gravity is with you, a silent, constant force gently holding you to your bed. It's the reason stars exist and the reason everything in the universe is held together. Long ago, before galaxies or light, gravity began its patient work, pulling scattered clouds of matter into clumps. Over eons, these clumps grew denser, heated up, and eventually ignited a star. Gravity, though quiet, is the force that births fire. Einstein's insight: it's easy to think of gravity as a simple pull, but Einstein's theory of general relativity offers a different perspective. Imagine space as a vast, stretched quilt. When you place a heavy object like a planet on it, the fabric curves. If you then roll a smaller object nearby, it moves toward the heavy one, not because it's being pulled, but because it's following the curve in the fabric. This is the essence of Einstein's idea. Gravity is not a force pulling across space, but rather the shape of space itself. Mass tells space how to curve, and curved space tells objects how to move. This is why the moon orbits Earth. It's following a curved path through spacetime. Black holes are an extreme example of this. creating deep punctures in the fabric of space from which nothing can escape. You are constantly moving through this curved space, which is why you feel weight. Gravitational waves, the cosmic murmur even in the deepest silence of space, the universe speaks through motion and gravity. When two black holes begin their inward spiral, they create ripples in spacetime. Imagine dropping a stone into a still lake. The ripples that spread out are like these gravitational waves. They don't move through space but are space itself stretching and compressing. As the black hole's orbit tightens, the waves become more intense. In 2015, humanity heard this chirp for the first time with an instrument called LIGO, the Laser Interferometer Gravitational Wave Observatory. It detected a ripple that had traveled for 1.3 billion years from the merger of two black holes. It was the first time we didn't just see the cosmos, we felt it. After the merger, the new black hole shudders like a cosmic bell ringing, sending out faint final waves. The passage of time is not as constant as it seems. It can change, particularly under the influence of strong gravity. This is known as gravitational time dilation, and it is a powerful truth from Einstein's theory of general relativity. The stronger the gravity, the slower time moves. For instance, time on Earth's surface passes slightly slower than it does in the clouds. Near a black hole, this effect is extreme. If you were to hover just outside a black hole's event horizon, time for you would slow to a crawl while the rest of the universe raced ahead. You could spend a few minutes there and return to find that millions of years had passed on Earth. If you were to cross the event horizon, you would appear to an outside observer to freeze in time, becoming a lingering echo. Time can adapt, it can slow down and stretch to hold memories, and in the presence of great mass, it grows patient. The origin of black holes revisited. To truly understand black holes, we must start with the death of stars. Every black hole begins with a star. A star's life is a delicate balance between the inward pull of its gravity and the outward push of nuclear fusion. When a star burns through its fuel, this balance breaks and gravity wins. The core collapses in a cataclysmic event, a supernova, and if the star is massive enough, the collapse continues beyond atoms, creating a black hole. It doesn't explode into existence but simply becomes a place where the escape velocity is faster than light. A black hole is not a monster but a memory, a story told in gravity, born from light and carried forward in silence.